right now it's working, so I'm gonna roll with it. So as I said, my name is Adrian Fernandez, and I manage our TI microcontroller development portfolio. So we have a whole bunch of development kits that we offer engineers, specifically IoT, to help them get up and running very quickly with prototypes and then ultimately get to production. And what I will start off with here today is a demo. The PowerPoint, we can get to that, but really the main thing I wanted to showcase here is, again, that sort of interaction that we have with various cloud services. But the first place I'll take you here is ti.com/launchpad, or I'm sorry, ti.com/IoT. So this is a portal page that you guys can go ahead and visit and see the various cloud services that we support. If you click on the Cloud Solutions tab, scrolling down here, you'll see some of the partners that we work with. So as I mentioned, over 25 different cloud partners that we work with, from the big guys all the way down to some of the smaller ones. So you see some familiar names like AWS, IBM, Bluemix, Microsoft Azure, so on and so forth. But we're also working with some of the smaller ones as well. The demo that I'll be running through today is actually with a company called Tembu. Has anyone heard of Tembu here? Okay, cool. Well, I'm actually excited that no one raised their hand, because I think what you'll see, you'll be pretty blown away. I think you'll be really excited about some of the integration that we have with that particular cloud partner. But what's cool about this is that this isn't just a marketing page. This is the resource page for your developers. All of these links here are clickable. You just simply click on any of these, and they will take you to a tutorial, some documentation, some training in terms of how to get TI hardware working with that specific cloud service. So in this case, this is PubNub, a pub sub kind of a communication protocol, and we have support for them as well. But again, in this particular instance, the demo that I'll be showcasing is with a company called Tembu. So let's go ahead and take a look at what Tembu does. I'm going to go ahead and click on their page here. And Tembu, what they are, they're an API aggregator. So you guys are familiar with RESTful APIs, right? Websites expose services, APIs to each other to exchange data. It's this sort of API economy. ESPN can exchange data with weather.com, who can exchange data with Facebook, so on and so forth. And that's just the way the internet has interacted with each other for eons, right? But now that I have microcontroller development boards, I have one here. This one here is the TI Launchpad kit. If you can't see it, it looks like every other hardware. You've probably seen several of them here today. But it's a TI microcontroller right there in the middle. And this does have an integrated Wi-Fi chip. We have single chip solutions, which is an ARM M4F with Wi-Fi built into the same chip. So with a single chip, you have a reprogrammable microcontroller and Wi-Fi integrated. And now that I have little tiny 32-bit ARM MCUs that can interact with the cloud, I can talk the same REST APIs that the internet and web services and websites have already been using. I can tap into that and make my embedded applications more intelligent. And that's what Tembu helps us do here. So I'm going to go ahead and I already have my account set up. You guys can do everything that I'm about to do here today. And I'm just going to go ahead and click on the Tembu logo here. And here on the left are all the cloud services that Tembu has support for. These are all websites, services, etc., that have a RESTful API that they expose externally. And if I wanted my little tiny microcontroller board to blink an LED when my package arrives from Fedex, the sort of quote-unquote old-fashioned way would be me having to get up and running with a SDK. I need to learn about how to do my HTTP client library with my microcontroller. I then have to go to fedex.com, create a developer account, read their API documentation, and then implement that on my own. But what we've done is with our SDK, we provided these APIs to these various cloud services, and Tembu is actually going to generate code on top of our SDK to enable your microcontroller device to interact through that RESTful API. And I'll show you what I mean by that. So as an example, we said FedEx, right? We buy stuff from Amazon Prime all the time. I want to blink the green LED when my package arrives at my front porch. I go here to FedEx, tracking and visibility, track by number. And here we have tight integration of our TI hardware with this particular cloud service. So I just say, hey, Tembu, I'm using my TI Wi-Fi chip, the CC3100. I'm connected in this way, and this is where I can put in my SSID and my password, my Wi-Fi credentials. So let's go ahead and put that in. These are just placeholders for now. Hit save. And now Tembu knows how my hardware can connect to the cloud. I provided it with my sort of home Wi-Fi credentials. And then here is where I can put in my FedEx information. I just provide my FedEx account number, my FedEx authentication key, and then ultimately my FedEx tracking number. And with those three pieces of information, Tembu has everything they need to generate the code on top of my Wi-Fi SDK to enable my Wi-Fi-enabled microcontroller development board to talk to the Fedex server. And you can actually scroll down here, and you see the complete code here. So this isn't just a code snippet. This is a complete project file that I can hit copy and paste into my IDE of choice. We have Arduino-based IDEs. We also have full-blown IDEs as well, Code Composer Studio, which is our Eclipse-based IDE. We just recently announced a cloud-based IDE as well, so you can actually do your cloud development with a cloud-based development environment called CCS Cloud. But in this case, I'm just going to go ahead and use Energia. So I'm just going to go ahead and paste that code that we generated and program my board. And I already programmed it, so it's a little bit like a cooking show, just to save you from the compile time. But I've already programmed this particular board, so I'm going to go ahead and plug it in over my serial port so you can see what my Launchpad's trying to do now. So bear with me. I switched laptop.
Test, yeah.
Test, okay, cool. All right, so like I said, I already programmed this particular board with the code that we generated. And what this particular demo is doing, it's a little simple. What Tembu does is it generates the code to enable my Launchpad to ping the Fedex server every 30 seconds. And my Launchpad will receive a string that says delivered, pending, out for, delayed, whatever that response might be from the Fedex server. And now me as the innovator, the programmer, I can do whatever I want with that information I just extract from the cloud. I can add that simple if statement that says if status equals delivered, let's go ahead and turn that green LED on. So this kind of takes care of the sort of cloud hardware interface for you. And then you as the innovator, the application developer, can add whatever secret sauce you want around that. So that's pretty cool. The Fedex demo's a silly one. We have another one. Nexmo is another cloud service. I don't know if you've heard of these guys. They're similar to Twilio. They provide RESTful APIs for triggering SMS or voice calls. That's a very common use case for an embedded device, right? It might be deployed in the field. I might be reading a sensor. I trip a particular threshold. I want to call somebody. I want to let them know that, hey, there's something going on here. And Nexmo provides, again, RESTful APIs for doing that. And just like the Fedex example, I just choose the RESTful API I want to use, in this case, text-to-speech. Just like before, I provide it with a couple parameters like my Nexmo API key, my Nexmo API secret key, and then this is where I can type the message that I want to vocalize to the end user. So I can say, hey, Adrian, your house is flooding. Flooding. Good luck. Cool. And that string is going to be sent to the cloud using their RESTful API. My Launchpad is going to send it up to the cloud. The cloud is going to take that text and vocalize it, doing some text-to-speech. And then it's going to trigger that voice call and call my phone. And I simply have to provide my cell phone number here. Cool. And then again, it generates a code for me. In this case, it's going to call my phone every 30 seconds. So similar to the Fedex example. Every 30 seconds, runs that API, I get a phone call. 30 seconds later, I get a phone call. Not ideal. I don't want that. I only wanted to call my phone when a given I/O event happens, like maybe an analog sensor value exceeds a particular threshold. And Tembu's actually already done that as well. I just scroll down here and pick which pin I care about. I have an analog sensor pin hooked up to pin 6.1. And I just say, hey, there's a sensor hooked up to that. It's a, let's say, a liquid level switch. And I'll name it water and hit save. So now I can actually trigger that RESTful API to be called only if my moisture sensor is less than, greater than, or equal to the threshold I care about. So let's say it's 200. And then trigger just once a day. So I scroll down to my code, and what was previously calling my phone every 30 seconds now only calls my phone if sensor value is greater than 200. So it dynamically generated that code. Without writing a single line, I created more or less a fairly intelligent Wi-Fi connected moisture sensor that I can maybe put underneath my water heater, right? And my water heater overflows, I get notification, and I don't have to worry about a flooded garage, so on and so forth. In this case, it's a moisture sensor, but that could have been any sensor. It could be pressure, it could be temperature, it could be humidity, so on and so forth. And in this case, it's going to generate the code to help my Launchpad call my phone. So just like before, I hit copy. I paste it into my programming environment, and I'll be able to program my board. So I've got a Wi-Fi hotspot here that I need to turn on. That's why it says Wi-Fi failed. It's trying to connect to the hotspot that I set up earlier. So I'm going to go ahead and turn my hotspot on. Cool. And now it should connect here. Let's give it a second. Actually, I'm going to go ahead and reset. Oh, there we go. I'm going to reset the board so you can see what's going on here. So the first thing it does is it tries to connect to Wi-Fi. I provided my Wi-Fi credentials earlier, if you remember. So it knows exactly what my SSID and my password is. I turned on the hotspot on my phone. It's able to connect to Wi-Fi. It says, great, I'm connected. And now it's going to start pulling that sensor. As a stand-in for my moisture sensor, I have a little potentiometer knob here. I don't know if you can see it. And what I'm going to do is I'm going to slowly turn the knob, and we set the threshold to 200, right? So I shouldn't generate any phone calls until that threshold is met. And what I'm going to try to do, I'm going to put my phone on speakerphone so you can actually hear the message that was translated from text to speech in the cloud. So I'm going to make sure that I have speaker enabled and my phone is in max volume, and I'll hold it up to the microphone, and we'll see if it works. We'll give it a try. Cool, so I'm slowly turning the knob now. Cool, value's getting dangerously close. We set the threshold for 200. There we go. Now it's triggered the API. My Launchpad, you see response 200. That's usually a good thing. My phone's ringing, if you can hear it. Maybe. I'm going to try to quickly put it on speakerphone. We'll see if this works.
Adrian, your house is flooding. Good mom.
There we go. I don't know if you guys heard it, but it said, hey, Adrian, your house is flooding. Good luck. So now it's not calling my phone anymore, even though my sensor value is exceeded. I said only call my phone once a day, so it's skipping it. But just like that, in like 2 seconds, right, we created a fairly intelligent Wi-Fi connected moisture sensor. And that's just the one example that we decided to run through. As I scroll through these other cloud services, you'll probably start to think of other use cases that you can enable. You see Uber is on there. We actually have an alcohol sensor plugin for this board. So if you blow too high, maybe, we can trigger an API call and call an Uber for you. What else can we do? Zillow, the market's pretty hot right now. You find a house that meets your needs, we can go ahead and buzz a buzzer or blink an LED on your Launchpad. I mean, the list goes on. It's really up to you guys to kind of figure out what kind of cloud information can I use to augment the real world or vice versa. One of my other favorite examples, for the folks that don't understand IoT, I think everyone here gets it. One of my favorite demos is Wolfram Alpha. Who's familiar with Wolfram Alpha? So I'm going to go ahead and pull it up here. It's basically like Google on steroids. It's mostly math related, so I can give it like a ridiculous math question. So as an example, let's see. Okay, arbitrary. But it gives me the answer back in different number formats. So my little tiny microcontroller running on a coin cell, I can actually offload that really hard math question to the cloud. And I can have the cloud give me the answer back in whatever format I want. And then at that point, I can go ahead and blink that LED or buzz that buzzer or spin that motor. So this is, I think, is just a very small example of what's possible now that I have these little tiny low-power microcontroller boards from TI talking to the cloud. I can take advantage of that. I can even ask it kind of silly questions like this one, like what color is the sky? And it gives me like the RGB color swatch. I mean, it's out of control. So this is just a very simple glimpse of what's now possible, right? That my little tiny microcontroller board can talk to the cloud. And folks like Tembu make it extremely easy, where I simply go to Wolfram Alpha query, I'm using a TI Wi-Fi booster pack with my development board. I do need a Wolfram Alpha account, so I just provide my Wolfram Alpha app ID and then the query. That could have been the math question. That could have been what color is the sky. That could be what's TI's stock price, et cetera, et cetera. And as before, it generates that code for you. So this, I think, is a clear example of how TI and the various cloud partners that we're working with were lowering that barrier of entry. These development boards start at just $12.99. So for 13 bucks, you get the hardware you need. You can program them with cloud services like Tembu, one of the 25 that we support. You guys are well enabled to start innovating with our chips. So that's, I don't know how much time I have. I know I was supposed to start at 3:20. It's 3:25. I've got a whole bunch of time. So we can hang out. So I'm just scrolling through here. A few other examples that I like to show off whenever I give these kind of demos is Google. Their entire suite of cloud tools are available. One of my favorites is Google Spreadsheets. So you can actually do a very, very simple, rudimentary, cloud-enabled data logging. Whenever a sensor value exceeds a threshold, let's go ahead and append a row to Google Spreadsheets, right? Add a timestamp, add a location, add a sensor value, whatever that might be. And then suddenly that's now data logged, and you can do further analytics there. Another cool example is DenDesk. I'm not sure if you're familiar with those guys, but they're a cloud service for service tickets. So if I wanted to embed a TI Wi-Fi chip into my next washing machine, maybe I want to create a service ticket whenever a particular sensor value exceeds a threshold. Or maybe I can do some sort of algorithm to try to predict when service might be needed. And I can go ahead and use the DenDesk API to create a new service ticket. Here's the tickets, create ticket. And just like that, you go ahead and interact with your cloud service, and you can have a service guy go and take care of business. Yeah, totally. In terms of commercial products, the question is, what types of applications are we enabling? It's all over the place. For Texas Instruments, our key focus area is connected, smart, industrial sort of environments. That's where I think we excel at. We have very low power microcontrollers. So this device here, even though it's Wi-Fi enabled, we can run on 2 coin cell batteries for a year plus. Depending on how often you're connecting to the cloud, how often you're transmitting data, we can extend that even further. But low power is very important to us. In addition to Wi-Fi, we support Bluetooth Low Energy as well as sub-gigahertz RF radio technology. So that enables you to get even better battery life. And with that I think enables us to really start to do more at the edge. So when you think about IoT, we want to make sure that we're only sending data up to the cloud when absolutely necessary. We can actually do a lot at the edge. We can do some math there. We can do some algorithms. And only when a certain threshold or a certain sort of event occurs, only then do we interact with the cloud. And that just helps you scale a little bit more. You don't want to clog the cloud up with data if you don't have to. And that just, I think, helps you scale from a commercial perspective, because that data interaction between you and your cloud service, it does add up, and it will cost you. So we want to make sure that we're doing as much as we can at the edge to help preserve some of that. Let's see here. A few other things that I'll share is a new product that we just announced called SimpleLink. So let me pull up the landing page here. So at Embedded World in Nuremberg about 2 weeks ago, we announced this new platform that we call SimpleLink. It is the broadest wired and wireless portfolio of ARM-based MCUs in the market. We have support for BLE5, which is actually the newest Bluetooth Low Energy spec. It doubles the range as well as the data throughput. We also have sub-gigahertz RF devices, and then again the Wi-Fi device, which is what I'm using here. But what's powerful about that is all of those devices are using the same SDK. So in addition to releasing what we call the SimpleLink portfolio, which is this collection of devices from Wi-Fi, BLE to sub-gigahertz, we have the same SDK that supports all those devices. So we actually have 100% application code portability. So if you built a thermostat, for example, and you wanted a Wi-Fi implementation of that, a lot of that code is going to be reused. If you want to then create a BLE variant or a BLE flavor of that, you can actually port that application over from device to device. And you as a customer can actually proliferate a complete portfolio of connected thermostats very easily while kind of maintaining and preserving that software investment. And that's something that we're very excited about. In addition to the TI SimpleLink SDK, we're also working with third parties and partners to develop plugins that depend on our SDK. So Bosch, for example, we're working with them to create sensor I2C drivers that build on top of our SDK. And that API for their accelerometer will work across our SimpleLink portfolio. So we're really, really thinking about software reuse in this particular product line. Here's a kind of a glimpse of that MCU portfolio. So as you can see, we have the various protocols covered. These are all ARM Cortex-M4F devices. Very powerful, but also very low power. And then we're actually integrating that RF connectivity into that chip. So it's a monolithic solution, which should help you with board space, for example. Because I know for a lot of connected products, you kind of want to keep that form factor as small as possible. And we're definitely sensitive to that. And then in addition to the chips, I'm using one of the Launchpad boards here. We have basically a Launchpad development kit for every one of those devices. So again, starting at just 13 bucks, you get a complete development board that has a built-in programmer. So you just plug it in over USB, and you're ready to go. You don't need any external components to start programming or debugging. In addition to that, these do feature a consistent connector. So you can actually see they have a similar silhouette, similar form factor. And this is a sort of a dock, if you will, for accepting plugin modules. So we have a portfolio of plugin modules that we call booster packs. We have about 80 plus different booster packs today. And that enables you to add on sensors, displays, battery packs, etc. So you can start prototyping very, very quickly. And every one of these Launchpad and booster pack kits are open source hardware. So all the schematic and layout files are available on ti.com. So once you have that stack of boards, you have it working, you've used our software to develop that prototype, you can actually go to our website to download the design files and replicate how we enabled the antenna design, for example. So you don't have to go and reverse engineer that on your own. We provide those source files freely on the web. And then probably the one last thing I'll share here is this new Resource Explorer. We understand that these products are getting more and more complex. Your customers are demanding more from you, just like you are relying more and more on us. And what we've done to help enable developers quickly is create what we call Resource Explorer. This is a complete repository of SDKs, documentation, code examples, resources to help you get up and running. So if you're using, for example, the BLE device, the CC2640 SimpleLink product, you can go here to see all of the documentation in one place. You can see some examples on how to do different BLE products. And we provide these code examples here. And what's great about these code examples is, well, let's say you find something that makes a lot of sense for you. Like here's an Eddystone beacon example. I can actually go ahead and look at that code. But then ultimately, I can actually import that into our cloud-based IDE. So with a single click, you can go from exploring resources to actually embedding and developing on that solution. So let me log in here so you can see what that cloud-based IDE looks like. In the cloud-based IDE, that's completely up to you. If you don't want to do your development in the cloud, no worries. Just download it locally, resident on your hard drive, and then you can use our traditional Eclipse-based IDE environment. So it's loading here. And what's great about the cloud-based IDE is, you can pick up where you left off. You can go to your home laptop, you log in, and we have a cloud-based workspace for you. All your projects are there, and it just helps you kind of have a consistent, seamless development flow. And you can also share workspaces with colleagues, so it helps with some code collaboration as well. So we'll let that click or let that load, and you'll see the example that we just imported from our Resource Explorer. So that code example we imported was called Micro Eddystone Beacon. We scroll down here, you can see all of my different projects, but here we go, Micro Eddystone Beacon. So now that project that we found in our Resource Explorer, we've imported it. You can see the HAL, the drivers, etc. And then you can also take a look at the application source code. And you can actually modify this code, right? So this is all open source software that you can start developing. Hit the run button, that'll compile the code and ultimately flash your hardware. So if you actually plug your Launchpad over USB, take advantage of our compiler in the cloud, compiles your code, generates a binary for you, sends it back, and flashes your hardware over USB. And this is all free, right? You don't have to worry about licenses for the environment. Cool. So that's all I've got, guys. What I'll leave you with are, I guess, a couple of links. The first thing I showed you guys was ti.com/IoT. That was all of our different cloud partners that we work with. Let me see here. This one, ti.com/IoT, Cloud Solutions. Again, this is not just a marketing page. This is a resource page. Click on any of these, and it'll take you to a tutorial on how to work with these cloud services. Tembu was the partner that I did the demo with. Again, just one of the many services that we work with, but they are a fun one to prototype with, simply because of how easy it was for me to create those connected demos. And then the last thing I shared was a new platform that we released called ti.com/SimpleLink. And that's the new platform of wired and wireless MCUs that we just released, supported by that single SDK. And that helps you very easily create connected products, whether that's Wi-Fi, BLE, or sub-gigahertz. Cool. Thanks, everybody.